Alright, I'm going to run through with you how to do electron dot structures, or also how to do basically what they're called Lewis structures. So what I'm showing you right now is the basic periodic table, and you have the what we call the group A elements, and I've kind of shown you this already where you know that depending on where the elements are located on the periodic table with the group A elements, that tells you how many valence electrons they have, or basically the number of electrons in their outermost energy level. So for example, lithium right here, it has 1 in its outermost energy level, or beryllium, it has 2, and so on. So those are all color coded. So this works for the rows as indicated. Kind of ignore the color coding. It's more so just as they go down 4A, 5A, 6A, as you see. So you're going to use that to help you with drawing Lewis structures. So we'll go through a couple of examples. Okay, so let's say that you want to draw a Lewis structure or electron dot structure for, let's say, lithium. Okay, so lithium is in group 1A, which means it has 1 valence electron. So what you have to imagine, you're not going to draw this, but you can just kind of imagine like there's an imaginary box around lithium. And there's only a couple rules about electron dot structures. And like with lithium, it's not as big a deal because you only have 1 electron, but with some other ones, it'll be a bigger deal as far as the rules go. The rules is that each side gets 1 before you start doubling, and that you have to go on each side of the box. So like in this case, it doesn't really matter which side of the box you start. I'm just going to put it here on top. So that's kind of what it visualized. So without the box, this would be the electron dot structure of lithium. Okay. All right. Okay. Go back. Okay, let's say we're going to do the electron dot structure of oxygen. Okay, so oxygen has 6 valence electrons because it's in group 6A. And so this is where the rules apply. So you would go 1, 2, 3, 4, and then it's your choice where you put the next 2. So you could go 5 and 6 if you want. But notice that each side gets 1 before you start doubling. So there would be the electron dot structure of oxygen. Okay, we're going to do one more. And that last one we're going to do is helium. Helium is a weird one because helium is actually in group 8A. And so normally all 8A elements would have 8 electrons. But helium is weird because if you notice, it has 2 protons because it's number 2 on the periodic table, which means it has 2 protons, which means it only has 2 electrons. Well, it's in group 8A because it acts like the other noble gases. Its outer shell is filled, it's happy with 2. So helium is the one rule breaker in our electron dot structures. So normally you would go, okay, 1, 2 with the rules, but we don't do that. to show that it's happy, what we do is just we put both dots on both sides to show that it falls in the noble gas category and that it's got a full valence electrons. And that's basically your electron dot structures.